So students, today we are going to solve the JEE Advanced 2014 question, and the question is from gravitation chapter. Okay, to solve this question you should know some basic formula. We will review all those basic formula and then we will solve this question. So let us read the question first. A planet of radius r by 10 radius of Earth. So there is a planet of radius which is 1/10 of radius of Earth, and that radius is given r. So here I have drawn a planet with radius, let's say this is center of planet, so this radius is, let's say, r. Okay, and this r is 1/10 of radius of Earth. So radius of planet is 1/10 of radius of Earth. So we can write RE by 10. Has same velocity, has same mass density as that of Earth. So this is an important data. It has same mass density as that of Earth. Now scientists dig a well of depth r by 5 on it. So let us dig a well of depth r by 5, and there is depth of this is r by 5. Obviously depth is measured from surface of the planet, right? And lower a wire of same length. Okay, they lower a wire, so let's draw a wire in the diagram. Let's say this is a wire of length which is r by 5. Okay, so there is a wire which is dropped in the well. Okay, now same length and linear mass density of the wire is given 10 raised to minus 3 kilogram per meter cube. Okay, wire is not touching anywhere, fine. The force applied at the top of wire by a person holding it in place is. So now we have to find a force applied by a person holding it. So obviously if this is a wire, okay, if you have a wire, let's say vertical wire, and you are holding that wire from this point, let's say, okay, so you are holding a wire, so you are applying force F, and that force will be equal to weight of the wire, which is mg. So what we have to find is this weight of the wire, which is mg. Okay, so weight equal to mg we have to find, but here it is not that straightforward, because if you look at the length of that wire, it is r by 5, 1/5 of the radius of that planet. So we cannot consider this wire as a point mass, and we cannot directly calculate the mass and put a value of mg. So here value of g will be variable. So we have studied formula for variation of g with depth. So let us write that formula also. Let me write that formula here. So let me write that formula for you. So variation of g with depth is g bracket 1 minus d by r. In any physics book you will find this formula. Okay, so now the question is, while calculating mg for this wire, the problem is wire is not a point mass. So we have to find, what we have to approach here is, we have to cut that wire into small piece. So let's say we have this small piece of that wire, and length of that small piece will be dx, or let's say dr, length of this small piece. We will cut the wire along length, and length of one such element will be dr, and its mass will be dm, and its distance from the center, because we will be integrating it, so distance from the center is r. Okay, so our formula we have to modify in terms of small r. So what we can do from this diagram, from the diagram, if you see carefully, so the depth d from figure, depth d, you can write this depth d. Let me show by some another marker. So depth d, this depth d is total r minus minus small r, yes or no? So depth d at any point will be capital R minus small r. So depth d will be capital R minus small r, and if I put that value here, my GD formula will modify to G bracket 1 minus capital R minus small r by capital R. Remember that small r is the distance from center of Earth, so, and capital R is the radius of that planet, small r is the distance from center of that planet. Let's work out this, let us simplify this. So this will be G bracket, this will be 1 minus r by r, capital R, minus and minus becomes plus, small r by capital R. This is 1, this is also 1, both will cancel, so 1 minus 1 will become 0. So what you will be left with, gr by capital R, that will be GD. Now we have something G with at any depth d as a function of r. Okay, so now what we can do is, let us find gravitational force or force required to lift that small element dm. Okay, so that will be little force df, and force direction is upwards only. So how much will be the force dm? So df will be mg, instead of m we will write dm, which is mass of that small element, into g at that position, g at that depth. Okay, so let us put value of dm. So now how to find value of dm? I think you know this, but let me explain that again. So dm, mass will be density times length, mass will be density times length, density is lambda, length is dr, so mass will be, dm will be lambda dr. So you can put that here, lambda dr, and gd is your g small r upon capital R. Here this g in the formula is acceleration due to gravity on the surface of planet. Fine, so remember this data. Okay, now where this r is, small r is distance from center to our element dm. So from where we will start? We will start first end of the lower end of the wire will be here, and top end of the wire will be here. So these two will be the limits of integration. This r by phi is the length of the wire, so total r minus r by phi, 1 minus 1 by phi will be 4 by phi r, to capital R will be the limit of your integration. So capital R will be limit of your integration, 4r by phi to capital R. So let us find total force. df is the force on small element, force to lift that small element. So total force will be integration lambda g by r, these are constant, r dr, and limits of integration are from 4r by phi to r. Okay, let us simplify this. Lambda is constant, take it out. G is on the surface of that planet, we don't know the value, but it is constant. R is radius of planet, that is also constant. Integration r dr, and limits are 4r by phi to r. Okay, if you have any doubt, you can just comment in comment box, so that I'll clear your doubt. Okay, regarding the solution. Okay, let us simplify this. So lambda is 10 raised to minus 3, I guess. Yes, g we don't know, so let us put values later on. Let us simplify this first. So lambda g by r, integration of r is r square by 2, yes or no, and limits are 4r by phi to r. Okay, now let us simplify this. There is multiplication sign here. Okay, so this is lambda g by r, or 2 you can take out. So upper limit minus lower limit will give you r square minus 4r by phi whole square. So this will be lambda g by 2r, and this will be r square minus 16, square of 4 is 16, r square by square of 5 is 25. So what is 1? You can take r square also outside. So 1 minus 16 by 25. How much is 1 minus 16 by 25? So that will be 25 minus 16. 25 minus 16 is 9 by 25. 9 by 25 r square, that will be solution of this bracket, and that is what we have is lambda g by 2r. You can cut this r and this power 2 also, and what is left is 9 by 50. 25 to the 50, lambda g capital R. Yes, that's it. That's what we have found, but that's not the answer, because in options they have given answer in Newton. So we have to put the values also. Now the task is, they have given that r, capital R is radius of that planet, which is 1/10 of radius of Earth, and small g is acceleration due to gravity on that planet, which is not given, but we know that small g is g mass of planet upon radius of planet whole square. Mass of planet upon radius of planet whole square. Now one more twist is mass of planet is also not given. Radius of planet is given anyway. Radius of planet is how much? R by 10. So radius of planet is R, which is given. So we can put that value. Now the task is to find mass of planet. I think you know this basic idea that density of this planet is same. So we can write mass is equal to volume of the planet 4 by 3 pi r cube. It's sphere. So volume of the planet is 4 by 3 pi r cube into density. So mass of the planet is volume into density. So you can see 4 by 3 pi and rho are constant. So you can directly use logic that mass of planet is proportional to radius cube. Now here radius, relation between radius is 1 by 10 re. So if you use that logic, so mass of planet will be r, it is actually proportional to 1/10 cube of 1/10 re. So that will give you, it is proportional to re by 1000. How that 1000 came? It is cube of this 10, 1 by 10. 1 by 10 cube is 1 by 1000. So I can directly write here that this is g. Instead of mass of planet, I will write mass of Earth. So from this logic we can write mass of planet is equal to mass of Earth upon 1000. This is a shortcut way of finding the relation between mass of planet and mass of Earth, and I think you are an advanced student, so you should know these shortcuts. Otherwise the standard method is to write this equation, write same equation for Earth, and divide both the equations. 4 by 3 pi and rho will get cancelled, put value of r, and you will get this relation. That's a long method, time pass method. We should not waste time in exam. So this is mass of Earth upon 1000. Okay, that is mass of planet. Radius of planet is radius of Earth upon 10, and there is square also. So squaring will cut this and cut these two zeros, right? This will be r by 100, r square by 100. So 100 and this 2 will 0 will go, and we will have g m e by r e. This is radius of Earth, remember, r e square, and there is 10 also. And what is this term? Gm by r square is acceleration due to gravity on Earth, which is given to be 10. So 10 by 10 will give you 1. So g value is 1. Okay, so one thing we have found, g we have found, lambda is given, and r is also given. So let us now simplify this. So what is force that we have? Force that we have found was how much? 9 by 50 lambda gr. 9 by 50 lambda gr, and 9 by 50 lambda is 10 raised to minus 3. G is 1, just now we have calculated on that planet. R is radius of Earth upon 10 raised radius of Earth upon 10. So now what we have is 9 by 50 into 10 raised to minus 3. Radius of Earth they have given. Let us check the data. You have to use their data, and it is this much, 6 into 10 raised to 6. 6 into 10 raised to 6. So put that value here, 6 into 10 raised to 6 divided by 10. So this is 10 raised to 9 6 are 54 upon 500, and what you have is 10 raised to 3. So you can cut this 2 and this power also will go. So what you will have is 540 upon 5. So if you do the division, 5 ones are 5 and then 0, 5 is 40. So 108 Newton is your force, and that's the correct answer. Okay, so this is how we can solve the JEE advanced questions. You should know the formula, and in advanced question there will be calculation, there will be lot of symbol changes and all those things, but once you do practice you can solve these examples also. Okay, thank you all. If you find this video useful, and if this video has helped you in solving this question, please share this video with your friends so that it can also help them, and do subscribe this channel. Thank you all.